Hello everyone. In this video I am going to discuss one example to solve ordinary differential equation using modified Euler's method. In my previous video I told you what is modified Euler's method, and we have already solved one example using that method. If you want to watch it again, the description is given in the description box. Okay, you can just click on the link and you can watch it fully. Now we have a question that find the solution of the following differential equation by Euler's modified method for x equals to 0.05 and x equals to 0.1 by taking h equals to 0.05 correct up to 3 decimal places, where dy dx equals to x plus y equals to 1 when x equals to 0, or y0 equals to 1. Now before going to discuss regarding the solution, just for your information, look at the modified Euler's method once. Here given dy dx equals to fxy, this is the function or the differential equation with initial condition yx0 equals to y0. The modified Euler's formula is given by y n plus 1 r plus 1 equals to yn plus h by 2 f x n y n and f x n plus 1 y n plus 1 r, where r equals to 0, 1, 2 and so on. It depends on the problem that how much will go with the value of r. Okay, again y0 n plus 1 equals to yn plus hf xn yn using Euler's formula. Here n is 0, 1, 2 and other values. Okay, it is also depending on the problem. Now this equation is also called initial approximation, and this h also are the step size, that is the difference between two instances of x, that is x0 x1 or x1 x2 or x3 x4. So it is better to say two consecutive instances of x, the difference between these two. Okay, now coming to the problem again, we have the differential equation as dy dx equals to x plus y. So dy dx equals to fxy equals to x plus y, it is given already, we have this. Okay, now according to Euler's modified formula, the initial approximation for y1 equals to y10 equals to y0 h f x0 y0. From where we have get this one? From this equation. Okay, 0 n plus 1 y n h f x n y n. By the initial approximation we are putting n equals to 0 here. Just look at this, n equals to 0. If we put n equals to 0, it will be y0 y1, and we are getting y0 plus hf x0 y0, right? We are putting n equals to 0. Now after that, according to the modified Euler's formula, if we want to find out the value of y1, okay, then we have to put the value of n and r one by one. Okay, by putting r equals to 0, 1, 2 and putting n equals to 0. After that for y2, n will be 1, like that. Okay, so coming to this, n0 r0, y1 1 will become y0 plus h by 2 f x0 y0 plus f x1 y1 0 from this formula. Okay, n0 and r0 here. Now putting in 0 R1, we'll get this one, y12 equals to y0 plus h by 2 fx0 y0 fx1 y1. Similarly, by putting in this equation in 0 R2, it will become y13 equals to y1 plus h by 2 f x0 y0 plus f x1 y1 2. See, for all these cases f x0 y0 will be there plus the function, okay, with y1. Now how many times we have to calculate this y1, or how far we should go for the value, like y10, y11, y12, y13 and so on. Coming to this example first, after that we'll understand automatically. Now, given the initial condition, according to the question, the initial condition h equals to 0.05, the value of x0, this one is the value of x0, okay, so it is 0. And what is the value of y0? Y0 is 1. So x0 is 0, y0 equals to y0 equals to 1, and h equals to 0.05. These values we have already from the question. Now, as h is the step size, I told you that h is the difference between two consecutive instances of x. So x1 will be equals to x0 plus h, or it is also called the increase from the x0. Okay, now x1 equals to x0 plus h, so 0 plus 0.5, sorry, 0.05 equals to 0.05. so we have the value x1 as 0.05. see, in the question we have to calculate the value of y for x equals to 0.05. so we have got already one value of x. So for this we will find out what is the value of y1. So if we find out the value of y1, that will be one of our answer. Again, x2 will become x1 plus h. So what is the value of x1? 0.05. 0.05. Put the value of h also, 0.05. So we'll get 0.1. See, in the question, the next value of the x will be 0.01, right? So for this we'll get the value of y2. So we have to find out these two values, and those will be the answer, right? Now, according to the initial condition, initial approximation, okay, like here y10 equals to y0 plus h f x0 y0. Putting the values of y0 x0 and y0 x0 and h, we are getting this y0 1, y0 1, x0 is 0, and again y0 is 1, and h is 0.05. now according to the function fxy equals to x plus y, it is given on the question. See, so this will be f01 will be 0 plus 1. By calculating this, we are getting the answer of y10 as 1.05, right? Now, after checking the modified Euler's method, the first approximation here, y11 will be y0 plus h by 2 fx0 y0 plus fx1 y10, right? Now we are putting the values of y0, y10, x0 and x1. So also for h, all the values we are putting here. This is x0, fx0 y0. so according to the formula, it is formula given in the question. This one is 0 plus 1, 0 plus 1, and we are getting this 1.05 for the value of y10. We have just calculated before this, right? We have just calculated this one here. Got it? Now, after calculating, we have got this value 1.0525, right? Now, if we compare two values 1.0525 and 1.05, these two are not actually same, because we have to correct the value up to 3 decimal places. That means 3 digits should be there, and they should be same for two values, two consecutive values after decimal point, right? So 1.05 we have got for the first y1, then for the second y1, that is y11, we are getting 1.0525. Now if we are calculating y12, okay, by putting n equals to 0 and r equals to 1, right, from this formula. See, y12. Now putting all the values of y0, h, x0, y0, x1, y11, we'll get the value y11, we have got the value of 1.0525. So putting all these values, we are getting, after calculation, we are getting 1.0525. See, y12 and y11, both of them have the value 1.0525, 1.0525. Since y11 and y12 are same, correct to 3 decimal places, that is 052. So y1 will become 1.052. You can put 5 here because both are same, or you can just eliminate this and you can write y1 equals to 1.052, right? So for x1 equals to 0.05. Now next we have to calculate the value of y for x2 equals to 0.1 as per the question, x equals to 0.1. Now putting in the value of n and r in the same way, this n will become 1 and r will be 0, 1, 2 and so on. Okay, so coming to this, y20 equals to y1 plus hf x1 y1. See, why we are calculating y2? Because as you have seen here, for x1 we are getting y1, for x2 we are getting y2, because we have to calculate the value of y on the basis of the value of x, that is 0.1, right? So coming to this, by initial approximation, y20 equals to y1 plus hf x1 y1. This formula is given. It is the initial approximation formula, right? So by putting all the values, we are getting y1 plus h x1 plus y1 according to the function given in the question. Okay, like this one. So putting all the values, we are getting y20 equals to 1.108, right? After that, again we'll increase the value of r and we will get like these formulas, okay, and we'll get y22 equals to y1 h by 2 f x1 y1 f x2 y2 equals to y1 plus h by 2 x1 y1 plus x2 y2 1, and by putting all the values and elaborating the function, we'll get y22 equals to 1.1103, right? Now just check 3 digits after decimal point for this y2 1 and this y22, 1.110, 1.110. So up to 3 decimal point, okay, decimal places, they are correct. So since y2, we can write y21 and y22 are same, correct to 3 decimal places, so y2 is 1.110. Okay, we can eliminate this. So here we'll write y1 equals to 1.052 for x1 equals to 0.05 and y2 equals to 1.110 where x2 equals to 0.1, and these two values are correct up to 3 decimal places. So this is the answer for this given question, and we have solved already this given ordinary differential equation using modified Euler's method. So if you have any query, please do comment in the comment section. I will try my best to answer all the question. Thank you.